Hello everyone, good morning to all. Welcome to our channel Gate Metallurgy by C. Patel. Best of luck for your gate examination. It is approaching, so be hard and be cool also. Okay, now coming to the lecture part. Today we will discuss about some physical metallurgy questions which has been asked in previous years, and these are some of the questions which generally students feel doubt about it. So I'm going to discuss 4 questions. Okay, the first question is: in heterogeneous nucleation, the radius of the critical nucleus does not depend on. First one, the option is contact angle, undercooling, the surface energy of the interface between the product and parent phases, enthalpy change per unit volume of the product phase. So here in this question it is asking about the critical radius of the nucleus. So we know that R critical is equal to minus 2 gamma s by delta GV, and we need to remember that R square is equal to minus 2 gamma s by delta GV. It is for homogeneous plus heterogeneous, means the same equation is followed in both homogeneous case and heterogeneous case also. So here there is no any term of theta, that is the angle of the contact. So here it will not depend on contact angle. And if you see the second option, undercooling, and since delta GV is related with delta T, that is undercooling, so radius of the nucleus will depend on undercooling. The surface energy of the interface between the product and the parent phases, the surface energy, in the term we can see gamma s. So gamma s is related with surface energy, so it will also depend on the surface energy. So undercooling, enthalpy change per unit volume of the product phase. Here we have been given enthalpy change, and we know delta G is equal to delta H minus T into delta S. So this delta GV will be related with delta H, but during calculation we generally ignore this term delta H. So here, since it is given delta enthalpy change per unit volume, so generally while calculation we ignore this. So that's why this delta GV will depend on delta H, and since R square depends on delta GV, so R star will depend on delta H. So this is also not the correct answer. So what will be the correct answer? Contact angle. So you need to remember this. Now coming to the second question. The second question was asked in GATE 2009, and this is the question: hardenability of steel does not depend on the alloy content, grain size, amount of carbon content, amount of cold work. Now first we need to understand what is hardenability. Hardenability is basically ability to form martensite. And what is necessary for formation of martensite? There is need of carbon, some amount of carbon is needed, and if you add some alloying content, if you add a cobalt, then it decreases hardenability. You must be knowing about this. Cobalt decreases hardenability, and all other alloying elements like nickel, chromium, increases hardenability. And the reason for this is that when we dissolve cobalt in the metal, then what happens? Cobalt does not dissolve completely, so it forms cobalt particles in the matrix, and this cobalt particles helps in nucleation of perlite during transformation. We know that gamma transform to martensite during quenching. But if you provide some particles or nucleation sites, then it will try to transform into perlite. So that's why cobalt helps in transformation of perlite, and hence it decreases the hardenability. Okay, so coming to the options, alloy content. So this is the wrong answer. Alloy content have effect on hardenability. Grain size, grain size also has effect on hardenability, because if you take two cases, finer grain size and bigger grain size. So what happens is that when we take finer grain size, so there is more grain boundary area, and this grain boundary area acts as nucleation sites for the perlite. So hence perlite formation in fine grain material is more as compared to the coarse grain material. So if you take coarse grain material or the coarse grain austenite and then transform to martensite, then the hardness or the martensite amount will be greater in coarse grain material. So grain size, you also note the correct answer. Amount of carbon content. Carbon content has also effect on hardenability. You must be knowing about this. Like if you increase the carbon content up to 0.8, then the hardenability increases, and after that hardenability decreases. So you can find in the book also. So we are left with these options. Amount of cold work. Cold work basically does not have much effect on this hardenability, because if you suppose provide a cold work at room temperature, cold working is done at room temperature or below recrystallization temperature. But when we transform this from gamma inside, so what happens? To take this material to gamma phase, we need to heat above critical temperature. So this critical temperature recrystallizes, more or less recrystallizes every dislocations which are present, which are formed during cold working. So there is no effect on cold work, like since it generates more number of dislocations, so these might help as nucleation site, but there is no any consideration for that. So amount of cold work is the correct answer. Now coming to this question, the angle in degrees between the transmitted beam and the diffracted beam from a crystallographic plane with interplanar spacing of 0.234 nanometer using a transmission electron microscope operating at 125 kV will be. Okay, so here in the question it is given that we have the voltage 125 kV and interplanar spacing is 0.234 nanometer. Okay, now since electron is used in the diffraction, so you assume like this, there is one electron and this electron will be accelerated with velocity v if you apply a potential of Vt. Okay, so the first thing we need to find here is lambda, because we will use the formula lambda equal to 2d sine theta. because it is asking about the theta, the angle in degrees between the transmitted beam. I will draw the diagram. The diffraction takes place like this. This is the transmitted and this is the diffracted, and this is theta. Okay, and the diffracted beam, yeah, and the interplanar spacing is 0.234 nanometer. Okay, so here it is asking about transmitted beam and the diffracted beam. Diffracted beam is this one and transmitted this one. So this angle it is talking about. So this angle will be 2 theta. Okay, so now we will try to find this. Now, since electron is accelerated with potential Vt, so we know that EV is equal to half mv square, because this voltage gives some energy and this energy is converted into kinetic energy. So from here V is equal to 2 EV by m, root under. M is the mass of electron. Yeah, you can see here. M is the mass of electron. So, and applying de Broglie equation. What is de Broglie equation? De Broglie equation gives the relation between lambda and the velocity of the electron. So lambda is equal to h by mv, equal to h by m into v is equal to 2 ev by m. So I'll write this in complete form, 626. You need to remember this constant, or these constants may be provided, will be provided in the question paper itself, so no need to remember much, but you should, since you should be very prepared about this. And these are the constants which should be remembered. Mass is 9.1 into 10 power minus 13 to electron. What is the energy of one electron? 1.602 into 10 power minus 19. Sorry, what is the charge of one electron? 1.6 into 10 power minus 19 coulomb. And V here it is given 125 kilo into 1000 divided by 9.1 into 10 power minus 13. So if you calculate this, so this value will come around, lambda will come around, which I have calculated. So lambda will be, in your case, will be 3.47 into 10 power minus 12 meter. Okay, you can do this calculation. Now we'll go to second part. Since lambda equal to 2d sine theta, so lambda we know about this, so sine theta is equal to lambda by 2d. So theta is equal to sine inverse lambda by 2d. Lambda we have got 3.47 into 10 power minus 12, 2 into d is 0.234 into 10 power minus 9. So if you calculate this, then theta will come around 0.424 degree. Okay, but what we have to calculate? We have to calculate 2 theta. So 2 theta equal to 0.848. Okay, so this is the answer. Two theta equal to 0.848. So what is the correct answer? This one is the correct answer. Now there is one confusion which is related with this type of question, so I want to clarify this confusion. Some of you might be using this formula, lambda is equal to root under 150 by V angstrom. Okay, and to use this formula you need to remember is that the V which is written over here, V is in volt. Do not take in kilovolt. If you take in kilovolt, then lambda will be different, and according to that the answer will be different. So it is the trick here, because generally you might be doing for quick calculation you will put value of voltage as 125 in the same unit of kilovolt, and you will come around with some lambda, and then you will calculate some theta and you will take the answer. If you do make that mistake, then your answer will be 13.54 degree, which is wrong. So use this formula, but take V in voltage, not in kilovolt. So remember this. Okay, coming to the next question. Yeah guys, the next question is, it was asked in GATE 2003. So this is a more a problem of physical metallurgy, but it is given in mechanical metallurgy in chapter wise book. Now, a single phase aluminum alloy with a grain size of 5 micrometer and yield stress of 400 MPa is annealed at 500 degrees centigrade. The grain size increases to 15 micrometer after 30 minutes and yield stress drops to 300 MPa. You may assume that the time exponent in grain growth kinetics is 0.5. Okay, so the further annealing time increase the grain size to 25 micrometer is. Okay, so guys, here you need to remember this formula, and the formula is d1 by n minus d naught 1 by n is equal to kt, where n is grain growth kinetics exponent. Okay, so here n is given as 0.5, so this equation will turn d square minus d naught square equal to kt. So now putting the values which we have, so in the first case, okay, grain size increases from 5 micrometer to 15 micrometer in 30 minutes. Okay, so 15 square minus 5 square is equal to k into 30 minutes. The second equation will be and the annealing time that will be required to increase grain size to 15. In the second case, it increases up to 25. So 25 square minus 5 square equal to k into the time which we have to calculate. So guys, here again you have to remember, like the first grain growth has taken place from 5 to 15. So in the next equation, you don't put 15 here, you need to put d naught only, because d naught is the starting grain size at t is equal to 0. So you need to keep 5 only. So these are the mistakes which generally students do. So from here you will get time is equal to 90 minutes. Okay, and since this time is the total time from 5 to 25, so we already have from 5 to micrometer, we already have time 30 minutes. So what will be the time from 15 to 25? It will be 90 minus 30. It will be 60 minutes. Okay, so 60 minutes will be the answer. So this is the correct answer. Okay, now the flow stress in MPa when the grain size is 25 micrometer is. So this is a problem on hole patch reaction relation. So sigma equal to sigma naught plus k by root under d. So we'll put the values simply. When d is 5 micrometer, then sigma is equal to 400. You can see 5 yield strength of 400. Okay, and for 15 micrometer, yield strength drops to 300. So we'll put the values. K by 5 root under 5, and second case 300 equal to sigma naught plus k by root under 15. So now subtract this equation. So you will get 100 equal to k by 1 by root 5 minus 1 by root under 15. So solving this, you will get value of k, and that will be 529.05. Yeah. Now put value of k in equation 1. Or equation 2, whatever you like. Okay, suppose I put in equation 2, whatever you can put in 1 or 2, doesn't matter. So 300 equal to sigma naught plus k by root under 15. So 300 equal to sigma naught plus k is equal to 529.05 by root under 15. So sigma naught equal to 300 minus 529.05 by root under 15. So now we have to calculate sigma when grain size increases to 25 micrometer. So sigma is equal to sigma naught plus k root under t. So sigma naught we have got 300 minus 529.05 by root under 15 plus k. So k is 529.05 divided by root under